We'll continue our discussion of quadratics, first of all by looking at graphing these with all the information we have. We start with the fact that a quadratic equation can be written as ax squared plus bx plus c. It's a parabola when you've got this vertex hk, and there's a vertical line x equals h, which is your axis. So that's when we write it in vertex form, y minus k equals a times x minus h quantity squared. If the a term is greater than 0, that means here or here is greater than 0, it's a happy face parabola. If that a term is less than 0, meaning it's negative, we have a sad face parabola. Parabolas get wider when your a is, when your absolute value of a is less than 1, meaning it's really wide when you've got fractions, and it gets really skinny when that value is bigger than 1. Your y-intercept, you plug 0 in for x, you end up with 0, 0, and c. So your y-intercept is c. And then this, all of this here, that's part of the quadratic formula, and it actually starts giving us x-intercepts. So if you have b squared minus 4ac, and that value is greater than 0, then to find the x-intercepts, there's your quadratic formula. If the part underneath the square root here is equal to 0, then your x-intercept is negative b over 2a. If it's less than 0, that means you've got a negative under the radical. There aren't any x-intercepts. We are going to look very quickly today at finding x-intercepts only because that is something that you did in Algebra 2. You can use quadratic formula, you can factor, you can complete the square to find x-intercepts. Let's take a look at this equation. We're going to graph this equation, so what we're going to need are the vertex, the x-intercepts, and finally the y-intercept. Now this should be pretty easy. The y-intercept, that's negative 8. To find the vertex, we can complete the square. So we would have y plus 8 is equal to negative 3x squared plus 12x. From here, we would have to factor out that negative 3. So that would be x squared minus 4x. That's why you had to learn to factor. Now we figure out what's that thing we need to make this a perfect square. So half of negative 4 is negative 2. Negative 2 squared is 4, so we would say plus 4. We added plus 4 here. Over here, we have to remember to add 4 times negative 3, so we'll actually subtract 12. So now I know that the vertex is the point 2, 4. I can plot the mirror image of this point. So there's my axis. This y-intercept is 2 units away, so I'm going to have another point that's 2 units away on the other side. Now we need to find the x-intercepts. To find x-intercepts, you set the equation equal to 0. Sorry. And from this point, I would use the quadratic formula. Do you remember this? So x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. All over 2 times negative 3. At this point, I would just enter each one of these into my calculator, because in order to reduce it, I would have to factor the 48, write it in simplest radical form, and eventually I really just want a decimal anyway. I know that my value has to be somewhere between 0 and 4. Rather, my two values have to be somewhere between 0 and 4. So I will put into the calculator negative 12 plus the square root of 48 over 6, and then negative 12 minus the square root of 48 over negative 6. This 6 should also be negative. So I'll put both of those into the calculator, and it will give me my two intercepts. When I do this, I get 0.845. We'll just call that 0.85. And here I get 3.15. So when I graph these, 0.85 I can just sort of estimate is kind of there. 3.15, that's going to be kind of close to 3. It doesn't have to be perfect. But remember that when you graph these, parabolas are curvy. We're now going to look at some word problems. Here we are being asked to give a function. We're asked about maximum, we're asked about specific heights, and then when a ball will hit the ground. And the first thing they want is a function. So you need to know the formula. The height as a function of time is equal to the initial height plus the initial velocity times t minus 16t squared. That is if you are in feet. Some things don't change. This one is if you are in meters. So given our problem, we have an initial height of 75 feet and an initial velocity of 112 feet per second. So our formula now, I don't have a problem with you guys using your calculator on word problems, but you will have to show the function. So we get into our calculator. Now I know that I've got an initial height of 75 and a velocity of 112, and I'm looking for something to happen at 200 feet. So my y maximum of 10, not going to be enough. So I'm going to change that to maybe 500. I'll increase the minimum negatively, and I will make the scale 100 units. And let's see how we do. And there's a nice graph. So if I want the maximum, it shows up right here. Second trace, and I want a maximum. Number 4. It asks for something to the left of the maximum, so any place to the left is fine. You hit enter. Then it asks for a place to the right of the maximum. So now I need to move until I get to the right of that point and hit enter. If you want to move your cursor over to a guess, that's fine, but you don't have to. I have a maximum, essentially that's 3.5, 271. So the x value is the number of seconds. So 3.5 seconds to reach 271 feet. So the x is your number of seconds, the y is your height. The next one, for what interval is the height greater than 200? Well, that's easy enough. I go to my y equals, because y is my height, and I want to see 200. Now it draws a line. All I have to do is find the intersection of this curve and this curve, and it asks for a guess, so you want to put it near the point of intersection. And I've got 1.39. And then I have to do it again, because remember, the ball will go from 75 feet all the way up to 271, and then it will come back down. So it's above 200 right up in here. So I need to find this point as well. I want number 5, the intersection, first curve, second curve. For my guess, I need to move it over to that other intersection point. And I have 5.61. So for what interval of time? Well, from 1.39 seconds to 5.61 seconds after it's launched, it's more than 200 feet. And then finally, when will it hit the ground? The nice thing about these graphs is that it touches the x-axis when it hits the ground. This is one of the zeros, one of the roots. So second trace, option for 0. Now it still asks for left and right. So if you think about this, what's going on to the left of it? Well, it's sort of this direction, and then to the right of it, it's down. So the spot is already to the left, and I will arrow right so that I go past that x-axis, enter, enter again. And it will hit the ground. In 7.62 seconds. For this type of problem, we're actually given some data, and we want to come up with a quadratic equation that will fit it. Here we've got years since 1900, so 98, 99, this is 2000, 2001, and these are visits to the hospital in millions. So what you'll need to do is first go to Stat and enter for edit. Now I've got information here, but your L1 should be these numbers, L2 should be these numbers. So I'll have you pause and get your information input. From there, you'll quit and go back to Stat. Now we want Calc, and we want a quadratic regression because it asked for a quadratic model. And you can just hit enter. And what it tells you is that A is negative 1.3, so we can say y equals negative 1.30 x squared, that's a point, plus 283.16x minus 14,669.95. So if I want to know how many hospital visits in 2010, then all that means is my x value has to be 10. We should be able to, I'm going to go back to Stat, I'm going to go back to Calc, number 5.
This is just a test of the PA. This is a test of the PA.
Awesome. If you put in L1, comma, L2, you can go to vars, over to yvars, number 1 function, select y1, and what will happen, if I had done that one correctly, and put a comma there, this will show up in my y equals, and if I hit second table, I want 110. So you can do second window, have that start at 110. And it looks to me like in the year 2010, there will be
This is just a test.
there will be 686 million .31 million. Sorry guys, obviously I'm at school doing this, and if I pause, it means I have to restart everything. So hopefully you forgive me for the PA tests.